So I was asked by a couple of students to outline a strategy for how to go about factoring some of the differences of squares outlined in question number 6 on page 168. So I thought what I would do is I would create a couple of examples to kind of demonstrate the process, and then you could attempt some of the questions in number 6 a little bit more easily. So what I've done is I've created this example here, and it doesn't really look like a difference of squares in terms of what we've seen so far. So I just want to juxtapose it or compare it to a simpler difference of squares, and then you'll see how they really compare. So I'm just going to create my little line here, and I'm going to just use a simpler difference of squares. I'm going to say, okay, well, let's say instead this was x squared minus 16. And I said, factor this. Well, what would you do? Well, you would first create your two brackets. You'd put a plus in one and a minus in the other. And you'd take the square root of your first term and put it in the first position in that bracket. So an x and an x. And then you'd take the square root of your second term. So the square root of 16 is, of course, 4. And then you'd put that in the second position. So a question like the one on the left is a difference of squares. It's just not so obviously one. So for instance, I can think of this whole thing right here like my base in the second question. So what would I do? Well, in any difference of squares, I would first, again, set up my brackets. And I would put a addition in the first bracket and a subtraction in the other one. I would take the square root of my first term and place it in the first position of the bracket. So then I'm going to ask myself, well, what is the square root of x minus 5 all squared? Well, when you take the square root of a value, you undo a square. So the opposite operation of squaring is to take the square root. So what do I get when I take the square root of x minus 5 all squared? Well, I just simply get x minus 5. So that's what I'm going to put in my bracket in my first position. So let me do that. I don't even leave myself a whole lot of room here. So let me try to do this. X minus 5. And then x minus 5. There I go. And again, you know, this little bit here is representing the square root of x minus 5 all squared. And then I'm going to go ahead and just finish this question. So now I'm same as usual. I'm going to put the square root of my second term in each bracket. So as we saw before, that was a 4. But I'm not quite done because, as you can see, this is something that I can simplify further. So I'm going to go ahead and do that. Oopsies. So I can combine some terms here. So x minus 5 plus 4 is going to give me x minus 1. And x minus 5 minus 4 is going to give me x minus 9. Now the only caveat here is that if I go ahead and I try to expand this, I'm not going to end up with the equation that I started with. But if I really wanted to know if I got this right, what I could do is I could expand this guy and then combine, and I should end up, and then go ahead and expand this guy by foiling, and then I should end up with the same result for both of those questions. So that's one type of question that I'm seeing on page 168, number 6. So hopefully that will allow you to start trying some of the examples there. And there's another type of question I'm going to go through in a minute. So let me just clear my board here. All right, so there's this thing that happens in math where as soon as we see a fraction, we automatically seem to kind of freeze. But really, this difference of squares is going to be, we're going to tackle it in the very same way as we would any other difference of squares, which is that we're just simply going to say, all right, I have my two brackets. I'm going to put a plus in one, an addition in one, and a subtraction in the other. And then I need to say, okay, well, how do I get the square root, I'm going to do this on the bottom here, of x squared over 16? Well, the way that I go about that is I just simply take the square root of the numerator, so x squared has a square root of x, and then I'm going to take the square root of my denominator, which is 4. Square root of 16 is 4. And then I'm going to do the same, so then let me just pause and fill in that spot. So what am I putting in my first position here for both of these difference of squares? I'm putting x over 4. Okay, now I'm going to tackle my second factor, my second term in that difference of squares, which is the square root of 1 over 25 is what I'm looking for. And so, well, what do I do? Square root of my numerator, 1, is 1. Square root of my denominator, 25, is 5. So there I've got it, 1/5. Oopsies. Let me make that black. So now I'm going to put in 1/5 and 1/5. Done. Complete. So the last type of question that I want to do is one that is similar to the ones you'll see in question 11 on page 169. So this is a super fun difference of squares. I'm really excited to show you how to do this, and this is a higher level, more complicated difference of squares, and depending on your ability to factor, this might be a challenge. So I'm going to kind of try to explain to you what I'm seeing here. So what I'm seeing is I have two parts to this. I'm first of all noticing that this little section right here is a minus 16y squared. So I know the typical format for any difference of squares is going to be something like a squared minus b squared, right? So I'm sort of seeing this thing right here, this minus 16y squared, as sort of like my minus b squared. And then the rest of it, okay, so like in other words, this bit right here, oops, let me redo that. This bit right here as sort of being like my a squared. It just doesn't really look like that right now. So I'm going to try to help you to see that. Okay, so let me get rid of some of this junk here. All right, so what I'm going to do first is I'm going to put a bracket around this, because that is that a squared component that I was talking about first. And I'm noticing right off the bat that it looks like a trinomial. And so a trinomial, I know how to factor. And it's a simple trinomial because it has a coefficient of 1 besides my x squared term. So I'm going to create a little space for myself here to do some rough work. Okay. So when I look at this trinomial, I'm going to remember that I'm looking for two numbers that multiply to give me my last term. In other words, they're going to multiply to give me 25, but add to give me that middle term of minus 10. Oops, let me squeeze that in, minus 10. So when I look at this, I can quickly figure out, because, finding the factors of 25 is not too difficult. Minus 5 and minus 5. And let me just check that. Negative 5 and negative 5 will add to give me negative 10. So now I have my factors in order to properly factor this trinomial here, this thingy right here. So that's what I'm going to do. So I'm going to say, all right, well, that ends up being x minus 5 and x minus 5. So and now I'm just going to carry on with this minus 16y squared. Well, when I look at this, I can see that I can easily condense that by knowing that it's, I have a factor multiplied by itself. Well, rewriting to simplify, I can rewrite that as x minus 5 all squared, and then minus 16y squared. So now this trinomial is quickly starting to take the shape of that, a squared minus b squared format, right? So, where a squared is just x minus 5 all squared, and b squared is 16y squared. So now I'm going to carry on with this. So as we saw in the very first example that I did today, on this video at least, I'm going to take the square root, as always when I'm, performing a difference of squares. I'm going to take this, make one of these factors an addition and one of them a subtraction. I'm going to take the square root of my first term and put it in each of the brackets. So the square root of x minus 5 all squared is just simply x minus 5. And the square, so putting one of those in each of the brackets. And then I'm going to take the square root of my second factor and put it in each one of the brackets as the second term. So the square root of 16y squared is simply 4, oopsies, let me redo that in black. y and then 4y. So now I'm ready to, look to see if there's anything that I can simplify. Is there anything that I can simplify? No, not really. The only thing we might want to do is simply reorder this in terms of, descending degree, and alphabetical order. So just using our math conventions, I'm going to put x plus 4y minus 5, and then x minus 4y minus 5. And now I'm done. So again, just to review, how did I strategize around this question? I saw that I could see this polynomial as, as a squared minus b squared. My trinomial, I had to factor to get it into something that looked a little bit more like an a squared. And then I simply followed through with my difference of squares. So that was a challenging question, but I hope that that models for you how you might go through some of the questions from number 6 to 11 from the homework on difference of squares.